So you've probably been hearing the buzz about this thing called WebAssembly, or WASM for short. People are throwing around words like game changer, saying it's going to completely change the web as we know it. But beyond all that hype, what is it really? And what does it actually mean for the future of code? Well, let's dive in and figure it out.
You see, as WASM has gotten more and more popular, there's one question that keeps popping up. It sparked a ton of debate and maybe even a little bit of fear across the entire developer community.
Is this it? Is this the end of the line for JavaScript's long reign on the web? That's the big myth we're going to tackle in this explainer. And I gotta tell you, the answer might actually surprise you.
But look, before we can even get to that huge question, we need to make sure we're all on the same page. We've got to understand what WebAssembly actually is. What's under the hood?
Let's just start with the official definition from the Mozilla Developer Network, right? It calls WASM a new type of code, a low-level assembly-like language that runs with near-native performance. Now, the words to really focus on there are new type of code and, most importantly, near-native performance. That right there, that's its superpower.
So let's just break that down into 3 really simple points. First, and this is important, you don't really write WebAssembly. It's what's called a compilation target. That means you write your code in other languages like C++ or Rust, and then you compile it into WAssembly. Second, like we just said, its performance is just crazy fast. And third, and this is absolutely crucial, it's designed to work with JavaScript, not against it.
Yeah, this whole idea of partnership is baked right into his DNA. A WASM module can call JavaScript functions, and JavaScript can turn right around and call functions inside WASM. They can pass data back and forth, they can use the same browser features. It's a total two-way street.
Okay, so we keep talking about how fast WASM is. But why? How on earth does it get this near-native speed inside of a web browser? That's something developers have been dreaming about for years. To get it, we need to take a quick peek at how a browser's JavaScript engine actually works.
So think of it like this. When your browser gets a bunch of JavaScript, it can't just run it. Not at all. First, it has to parse it, kind of like a proofreader scanning for mistakes. Then, it has to translate that into a sort of intermediate language. Only after all that work can it finally compile the code into the instructions your computer actually understands and can execute.
And this is where it gets really interesting. Look at WebAssembly's path to getting executed. It's like it gets an express pass to the front of the line. It basically gets to skip those first 2 huge steps and go straight to the compiler. I mean, that is a massive head start.
Which, of course, leads to the obvious next question, right? How is that even possible? Why does JavaScript have to do all this extra work while WebAssembly just gets to jump the line?
The whole answer boils down to one simple concept: typing. See, JavaScript is dynamically typed. That means the browser has to figure out what kind of data is in your variables. Is it a number, a string, while the code is running? And that happens during that slow parsing step. But WebAssembly? It comes from statically typed languages, where all the types are declared ahead of time. So the browser gets this precompiled WASM module where all that info is already known, and it can just skip right ahead.
Okay, so the theory is super impressive, but is anyone actually using this thing in the real world? Let's take a look.
So back in 2019, some researchers in Germany scanned the top 1 million websites to see who was using WebAssembly, and they found over 1,600 sites loading WASM modules. For a relatively new technology, that's a huge deal. But what were they using it for?
Well, the results showed 2 things dominating. About 29% was for gaming, which makes total sense, right? You need high performance for games. But, and this is kind of wild, the biggest chunk at 32% was for cryptocurrency mining. WASM's efficiency was so good that it was even being used for some nasty stuff like cryptojacking on hacked websites.
But look, gaming and crypto mining, that's really just the tip of the iceberg. The real story, the exciting part, is how WebAssembly is making it possible to run these incredibly complex desktop-level applications right inside your browser.
Take Figma, for example. I'm sure you've heard of it, the super popular web-based design tool. By rebuilding their rendering engine with WebAssembly, they reported a 3-fold increase in loading speed. For users, that is a massive, you can really feel it kind of improvement.
And it's not just Figma. Autodesk, the giant, brought its legendary AutoCAD software to the web using WebAssembly. And their report? They got native-like speed. This lets them run incredibly heavy, complicated software in a browser tab, something that was pretty much a pipe dream just a few years ago. So, with all of that in mind, the technology, the insane speed, the real-world uses, let's circle all the way back and finally answer that question we started with.
The final verdict? It's really clear. WebAssembly is not a JavaScript killer. It was never designed to be one. It was never meant to be a competitor. It was always, always meant to be a partner.
You see, the future of the web isn't about one language winning out over another. It's about a powerful collaboration. JavaScript is going to keep doing what it's amazing at: managing the web page, handling clicks and user events, talking to all the browser APIs. And WebAssembly? It's going to step in for the really heavy lifting, the intense calculations that need raw, unadulterated speed. And together, they are going to unlock a whole new world of possibilities for web applications.
And that really leaves us with a pretty fascinating question for the future, doesn't it? I mean, we've already seen incredibly complex design software and CAD programs running in a browser. So if WebAssembly continues to close that performance gap between desktop and web, what kind of applications, maybe things we can't even imagine today,